We have been hearing a big data in the previous parts of this section. So what is big data? As a part of this, we'll try to understand what is big data. How do we define the big data? And if someone asks you what is big data, how do we really respond to that? Let us try to understand those aspects as a part of this part. So now what is big data? Big data is a huge amount of data that cannot be stored and processed in traditional database management systems. When I say that traditional database management systems, that can be relational database engines like Oracle, PostgreSQL, MySQL. So we have a lot of data in terms of size, in terms of volume, in terms of the amount of data. It can be structured, it can be unstructured, it can be semi-structured. That data cannot be stored and processed in database engines, that is traditional database engines. That is called as a big data. So that is how we define the big data. But when somebody asks you what is big data, we cannot really leave only up to this, wherein that the huge amount of data which cannot be stored and processed in traditional database management systems, we have to extend it further. We have to say that big data is also characterized by four important V's. Like one of the V is volume. The second V is velocity. The third one is variety. The fourth one is veracity. The fifth one is valence. Last one is value. So whenever someone asks for our understanding as well, what is big data? Big data is a huge amount of structured, unstructured, semi-structured data which cannot be stored and processed in traditional database management systems and characterized by four V's: volume, velocity, variety, and veracity. Along with that, we can say valence and also value as well. Let us look at them one by one. What is volume? Can you just think of what is volume? Volume is size of the data. Volume is size of the data, right? When I say size of the data, how did it come? We have in a way already discussed about how the data is being produced by different sources. But just to kind of get a hang of it, how the so much of data is being produced. If you look at the internet, we conduct more than half of our web searches from a mobile phone now. In a way, that has increased the traffic in the internet. And almost nearly 4 billion humans are using the internet now. On an average, Google is processing almost 40,000 searches every second. Imagine that. Almost nearly 3.5 billion searches per day. Isn't it humongous? Isn't it huge? It is. If you look at the social media, Snapchat users share around 5,27,000 photos per minute, and almost around 120 professionals join LinkedIn per minute. Almost nearly 41 lakh people watch the YouTube videos, and almost 4 lakh tweets are sent on Twitter. Instagram uses almost 50,000 photos per minute. And we do have a communication angle wherein that every minute around 16 million text messages are sent. Almost nearly 90,000 Tinder swipes are done. Almost 156 million emails are sent. The point I am trying to make here is we do have a volume. The size of the data is increasing day by day with the contribution from all these things like internet, social media, communication, and also the sources what we discussed like machines, organization, and also people. Now that we got a hang of volume, how do we really measure the data? Isn't it in a bit? What is a bit then? Bit is the smallest unit of data in a computer. It is a short form of binary digit. So either it will have a 0 or 1 binary value. So let us try to understand how do we really measure the data. Some of it already you know, but I want to take you to the next level. That is the reason I'm starting from a very basic. So if I ask you a question, how much is 1 byte? It is 8 bits. Very easy question, right? How much is a 1 kilobyte? It is 1024 bytes. How much is a 1 megabyte? It is 1024 kilobytes. How much is a 1 gigabyte? It is 1024 megabytes. How much is a 1 terabyte? It is 1024 gigabytes. What is the next level after terabyte? Can you just think of by passing a video? It is petabyte. For 1 petabyte, we have 1024 terabytes. In 1 exabyte, we have 1024 petabytes. Any idea what is on top of exabyte? It is zettabytes. We have 1024 exabytes in zettabytes. Above zettabyte, we have 1 yottabyte, which is 1024 zettabytes. So why do we really need to study all these things? Why do we really need to understand, is it measured in terabytes or petabytes? Imagine in an organization you want to work in a company. So because we are in a big data era, they'll say, hey, can you please process the 1 petabyte of data? If you unknowingly say, yeah, I will be able to process it in 1 minute, then you will not be understanding how much of amount of data is there in 1 petabyte. That is the reason in an era of big data, you need to understand how the data is measured, and 1 petabyte means how much and 1 exabyte means how much. Is exabyte is more than petabyte. We need to understand this. That is the reason we have included this as a part of the volume, the size. Now that we understood the volume, let us move on and understand how the data is increased over a period of time. If you look at in 2009, almost there was a data of 0.8 zettabytes then. Now, if you see in 2020, we have almost 36 zettabytes of data. It has grown by a factor of 44. That is how the data growth has been. That is the reason we are in an era of big data. Now that we understood what is the volume in case of the characteristics of the big data, we'll understand what is velocity. Any idea what is velocity in terms of the data? Velocity is the speed. Velocity is the speed at which the data is being created. Velocity is the pace at which the data is being stored. Velocity is the pace at which the data is being analyzed. So pay attention here. It is not only about the creation of the data. We need to be worried about the storage of the data, analysis of the data. Let us say the data is created, we dump the data in particular place. If we cannot really retrieve the data in a faster pace, then also it doesn't make sense. So we need to be worried about the pace at which the data is being created, stored, as well as analyzed. So in the era of the big data, the velocity at which the data is being produced is at a very faster phase. At a faster phase. So that is velocity of the data. Now let us understand the variety of the data. Any idea what is variety? Variety is nothing but a complexity of the data. We have 3 categories in terms of variety. One is structured, second one is semi-structured. The third one is unstructured. Now, in a structured data, do you know what is structured data? Structured data is nothing but what are the data you are seeing in a spreadsheet or the tables in RDBMS databases. Isn't it structured there because you have a rows, we have a column? That is the reason it is called as a structured data. Semi-structured data means the data which is there in XML files. The data which is there in JSON files. So we do the semi-structured data is neither structured nor unstructured. It is in a way in between structured and unstructured. So if we really open and look at the XML files or JSON files, we'll get to know we'll have a tags, we'll have a data stored in a semi-structured format. What is unstructured then? Unstructured data is like what are the text data like emails, we have status updates, we have tweets. That is a unstructured data. So now that we understood what are the different varieties of the data, we'll move on and look at veracity. What is veracity? Veracity is the validity or volatility of the data. It is in a way, what is the quality of the data? When we say quality of the data, it can be a particular data can be of a good quality in particular context. But the same thing may not happen in another context. So when we look at the quality, we always look at the quality in the context of that analysis. So whether the data is accurate or not, whether the data is reliable or not, that is signified by the veracity of the data. So remember, it is always in the context, within that context. That is how we look at the quality of the data. Now that we understood what is veracity, let us move on and understand the valence. If you go back to your chemistry classes during your high school days or college days, we used to use this particular term, valence. We used to say valence of electrons, right? If you remember. Okay, so we used to say valence of electrons. Electrons are revolving around proton and all those things. So now, in a way, we have derived that particular term here also. Valence is nothing but connectedness of the data. How well the data is connected to each other in terms of the analysis. That is what is valence of the data. In the end, we look at what is value of the data. Value of the data is derived by all these V's like volume, velocity, valence, veracity, variety. Value is the core. Value is in the central part of all the V's. So if we are not able to derive the value from a particular data, then it doesn't make sense. So these are the 6 V's in the big data. So what we discussed is what is big data and what are the different V's in big data. That is starting from volume, velocity, variety, veracity, and valence. In the end, value as well. Thank you.